Hello. Today we will be diving into inheritance in object-oriented programming. So first of all, you're probably thinking, well, I've heard of inheritance before. I inherit genes from my biological parents. And in my opinion, that's actually a great way to think about it. Inheritance in programming works kind of the same way. You have a parent or a parent class that defines certain traits, and then a child or child classes can inherit those traits, just like a kid might inherit their mom's eye color or hair color. So how do we actually make a parent class? How do we actually do this in Python? Well, we start with, here we can do class mom in this example. You can do class anything. Now, I like to imagine that I'm surveying random moms at a park. I pick someone and classify her as a mom. So I have this classification process going on and I make that mom class. Next, I want to write down what traits this mom has. Maybe eye color and hair color. So we define a special type of method called an init method like this with this line. Think of this as you are defining this mom on your sheet, and you do this by initially writing and starting to fill out a form on this mom that you are interviewing with columns, including eye color and hair color. And so you would write her name at the top of the page, represented by self, and then you would note her traits in the eye color and hair color columns. And we assign those traits with this lower box. Now, when I see a dot in code like self.i_color, I mentally replace it with the word get. So this line means to me, for this mom, self, when I get her eye color, I am now setting that to be whatever I input for eye color when I write down her details. So now we've made a way to classify individuals as moms with the mom class, and then define specific traits like eye color, hair color, and then and that's when we're creating a specific mom in our survey. So let's practice once with this. So creating mom objects. Let's say I meet someone named Stephanie, who is a mother with green eyes and blonde hair. So I can write her name down, Stephanie, and classify her as a mom. And then write her traits, green eyes and blonde hair. Then I meet another mom named Maria, who has brown eyes and white hair. And so we first classify her as a mom, and then I write her traits. Brown eyes and white hair. Later, if I want to know what color Maria's eyes were, I write maria.i_color. So let's actually map out what's going on here. So when I initially wrote down or initialized Maria with Maria equals, for this Maria object, it went through the mom class. And so we went to the mom class because I said she is of the class mom. And it came down to these traits. And the self is just her name. So this was Maria, and the eye color we defined as brown, and the hair color is white. And when I initialize, I say that self.i_color is set as the eye color that we just put in as brown, right? So we're saying it's set to this eye color, which we've just set in as brown. So self.i_color is really, since that's her name, it's really Maria.i_color, and we've just defined it as brown, so this is going to return brown. Okay, so now let's bring in inheritance. Let's say I meet a kid named Johnny, who is Stephanie's son. He will have inherited those general traits, like eye color and hair color from his mom, but he also has his own special traits too. So let's say we're going to ask every kid for their favorite instrument. We'll make a son class that inherits from mom like this. I like to imagine a kid holding onto his mom's leg, so we write the mom class inside parentheses, and I imagine the parentheses as the boy's arms wrapping around his mom's leg while we're performing this interview at the park. Then we define Johnny's traits just like with Mom's. We want to define him in our survey. So we initialize him by initially writing his name at the top of the page, represented by self, and then his traits, where we first list, just like with Mom, we do eye color and hair color. But now we have a special trait that's unique to all the sons we're interviewing, and that is their favorite instrument. So then I like to think of our analogy, and since we already made a column, an outline on our sheet for hair and eye color when we did Mom, we can essentially just copy those chart outlines we made earlier all at once with a method called super. And that means we're going to the super class, which is another name for the parent class. And we're going to get the outline for the traits that we initialized already, and we specify that we are getting the eye color and hair color. Then I need to make a new column or outline for all the kids' favorite instruments that we're going to write down. So we initially are going to be writing this chart for the favorite instruments. So to recap, the super refers to the parent class, the super class, which is Mom, and super in it means go to the Mom class and get the traits we already defined, those outlines, hair color and eye color. Then we add the new trait column, which is favorite instrument. And this self.favorite_instrument just means for this kid, self, when I get the favorite instrument, well, that is whatever I inputted when I wrote down his information during our interview. So how do we actually create a son object? So let's say I meet a boy named Johnny, and I classify him as a son. So Johnny is of the son class. So I write down his name, but Johnny's of the son class, and he has green eyes, blonde hair, and he tells us he loves to play the cello. Then later, if I want to retrieve what his favorite instrument was, I'm going to go to Johnny in my notes in my notepad, and then get the favorite instrument that I wrote down. So mapping that out, we go to Johnny, and he's of the son class, so we go to the son class, and we see that self.favorite_instrument retrieves the instrument that we put in. So when I interviewed him, he responded with cello, so we put that down. And so this statement is going to print cello. And remember, because Johnny inherits traits from Mom, we can also do this lower approach. And let's map this one out too, since it's a little bit more involved. So I'm going to Johnny, who is of the son class again, and I'm wanting to get his eye color. So then in that son class, that if I want to get eye color, this super actually redirects me to the parent class. So I come up to eye color in the Mom class, and I find that self.eye_color is equal to the eye color. So it's that same idea where since it's self.eye_color, that's really his name. So then Johnny.eye_hair color is this eye color that we're inputting, and so then it's going to print green. So just to recap, we use a parent class to define general traits that all classes will have. We create child classes that inherit those traits, but who also have their own special traits. We use super to avoid repeating code and access the parent traits, and we can always add new unique traits to the child class, like a kid can always learn a new trick or talent, but we always have those general inherited traits from the parent. So inheritance helps us keep code clean and organized. Thank you for listening.